Something is hiding at the edge of our solar system. Right now, while you're listening to these words, something may be moving through the dark at the edge of our solar system that almost nobody on Earth knows about. It is large, larger than Earth, several times heavier. It is so far away that sunlight reaching it is thousands of times weaker than the sunlight on your skin right now. Out there, the sun is not a disk. It is a bright point among other bright points. It is not a star. It is not a comet. It is not a rogue object passing through. And if it is real, it has been out there since before the pyramids, before the ice ages, before the first cell divided in the ocean, before the Earth had finished forming its crust. It would take between 10,000 and 20,000 years to go around the sun once. One orbit. If it began a lap when the last glaciers were retreating across northern Europe, it would still be working on that lap today. And nobody has ever seen it. We are not talking about a rumor. We are talking about a formal prediction, published in a peer-reviewed journal, based on the movements of 6 distant objects that should not be moving the way they move. The team that ran the numbers calculated the odds of that pattern happening by pure chance at roughly 0.007%. This is the story of Planet 9. And here is the part the headlines are not telling you. It is not just what astronomers found out there. It is what the search revealed about how little of our own solar system we have actually mapped. Right here, in the neighborhood we call home. It is what is happening to this hypothesis right now, in 2026, as a new telescope in Chile begins the survey that could end the argument. And it is what happens in the 2030s, a date already locked into the calendar, when that survey finishes, and we either have a 9th planet, or we have to admit, we were chasing a ghost. Stay with me, because by the time this is over, you will never think about the edge of the solar system the same way again. To understand why anyone takes this seriously, you have to go back almost a century, to a farm boy from Kansas with no college degree. In 1929, a 23-year-old named Clyde Tombaugh sent hand-drawn sketches of Jupiter and Mars to Lowell Observatory in Flagstaff, Arizona. He had made them using a telescope he built himself, partly out of parts from a cream separator and a 1910 Buick. The observatory did not offer him a scholarship. They offered him a job. The job was one of the most tedious imaginable. The observatory's founder, Percival Lowell, had died in 1916, convinced that an unseen world was tugging on Uranus and Neptune. He called it Planet X. Tombaugh's task was to find it. He would photograph the same patch of sky on 2 different nights, then load both glass plates into a machine called a blink comparator. The machine flipped between the 2 images, back and forth, back and forth. Stars stayed put. Anything that moved would appear to jump. Each plate could hold hundreds of thousands of star images. He blinked through them one small section at a time. He did this for 10 months. On February 18, 1930, working through plates taken on January 23 and January 29, he found a faint point of light that had shifted position. He checked it against a 3rd plate. It had moved again. He walked down the hall to the director's office and said he had found Planet X. He was 24 years old. The object was named Pluto. And here is the turning point that matters for our story. Pluto was not what Lowell predicted. Lowell's Planet X was supposed to be roughly 7 times the mass of Earth, massive enough to shove Neptune around. Pluto turned out to be smaller than our own moon. It could not tug on anything. The prediction that led to the discovery was wrong, and the discovery that resulted was a coincidence. For 76 years, that coincidence sat in the textbooks as the 9th planet. Then, on August 24, 2006, in Prague, the International Astronomical Union voted. Pluto was reclassified as a dwarf planet. The solar system officially had 8, and the slot that Percival Lowell had opened in 1906, the slot for something large and unseen out in the dark, quietly reopened. Here is how you find a planet you cannot see. You do not look for the planet, you look for its fingerprints. Gravity is not selective. A massive object does not only pull on things near it, it pulls on everything, forever, weakening with distance but never switching off. Out beyond Neptune, there is a vast population of frozen bodies, rock and ice, left over from the formation of the solar system. We call the inner part of it the Kuiper Belt. Most of those objects follow orbits that are scattered and random. That is what you expect. 4.5 billion years of nudges and collisions should smear everything into disorder. But a handful of the most distant ones are not disordered. The chain works like this. A massive body on a long orbit passes near a smaller body. Its gravity gives that smaller body a slight tug. That tug does not vanish. It shifts the smaller body's orbit by a tiny amount. The massive body comes back and does it again. And again. Over millions of orbits, tiny repeated tugs stop being random. They accumulate into a pattern. The small bodies get herded, their orbits pulled into alignment, their closest approaches to the sun clustered in the same direction in space. That is the fingerprint, not the planet, the alignment. It is the same logic that found Neptune. In 1846, Urbain Le Verrier studied irregularities in the orbit of Uranus, calculated where an unseen eighth planet would have to be, and mailed the coordinates to the Berlin Observatory. Johann Galle pointed the telescope at those coordinates and found Neptune the same night, within 1 degree of the prediction. But you should also know how the same method failed. Le Verrier tried it again on Mercury. Mercury's orbit was also misbehaving, so he predicted a small planet closer to the Sun and named it Vulcan. Astronomers reported sightings for decades. Vulcan did not exist. Mercury's orbit was explained in 1915 by Einstein's general relativity. The anomaly was real. The planet was not. Both of those outcomes are live possibilities here. Keep them in mind. Now consider what it would actually take to photograph this thing. The predicted distance is enormous. In the original 2016 paper, it was an orbit averaging around 700 times the Earth-Sun distance, swinging as close as roughly 200 and as far as roughly 1,200. A revised 2021 analysis pulled that in to an average of around 380. Take a working number of 600 times Earth's distance from the Sun. At that range, sunlight is not just dim, it is dim twice over. The light has to travel out to the planet, and it gets weaker with the square of the distance. Then it has to reflect and travel all the way back to us, and it gets weaker with the square of the distance again. That is a fourth power falloff. Move an object twice as far away, and it does not become 4 times fainter. It becomes 16 times fainter. At 600 times Earth's distance, an object roughly the size of Neptune would be something like millions of times fainter than Neptune appears. You are not looking for a dot, you are looking for a smudge at the absolute floor of what a telescope can register, in a sky already full of smudges. And it barely moves. A planet with a 20,000-year orbit crawls across our sky. That is the whole trick Tombaugh used. Motion between two nights. Out there, the motion between two nights is almost nothing. You need images separated by months, and you need to track a target so faint that it disappears into the noise of the background sky. There is also the problem of where to point. The search zone is not a neat window. It is a band wrapping most of the way around the sky, and part of it passes directly through the plane of the Milky Way, where the background is packed with hundreds of millions of stars. A faint, slow-moving dot in that region is close to impossible to isolate with the tools we have had. No probe is going there. Nothing we have launched will reach that distance on any human timescale, and nothing we have launched is aimed at the right part of the sky anyway. 6 aligned orbits, 10 Earth masses, 20,000 years, 600 times farther than we are. Those are the only numbers we have to work with. Everything that follows is built on them. Start with the finding that started it. In 2014, astronomers Chad Trujillo and Scott Shepard announced the discovery of a distant object catalogued as 2012 VP1113. Its closest approach to the Sun is about 80 times Earth's distance. It never comes anywhere near Neptune. Only one other object like it was known, Sedna, found in 2003 by Mike Brown, Chad Trujillo, and David Rabinowitz. Trujillo and Shepard noticed something odd. These extreme objects, plus a handful of others, all reach their closest approach to the Sun at a suspiciously similar angle. In their 2014 paper, they raised the possibility that a super-Earth-sized body far beyond Neptune was shepherding them. In January 2016, 2 Caltech researchers took that idea and ran it to ground. Konstantin Batygin and Michael Brown published in the Astronomical Journal. They took 6 distant objects with the most extreme orbits and showed that those orbits were clustered in 2 ways at once. Clustered in the direction of closest approach and tilted out of the plane of the solar system in the same direction. They calculated the probability of that double alignment arising by chance, roughly 0.007%, about 1 in 14,000. Then they ran simulations. A body of roughly 10 Earth masses, on a long, tilted orbit, reproduce the pattern. 6 objects. That is the entire foundation. It is worth sitting with how small that number is. A prediction only becomes science when it says something you have not already seen. The simulations produced a side effect the researchers were not looking for. A massive body on that kind of tilted orbit should, over long timescales, kick a small population of Kuiper Belt objects into orbits that are steeply inclined, some of them close to perpendicular to the plane of the planets. Objects standing sideways relative to everything else. At the time the 2016 paper was written, a small number of such objects were already known, but had not been connected to the clustering. The model accounted for them. That is the strongest thing Planet 9 has going for it. Not the clustering it was built to explain. The population it was not built to explain. Bodigan and Brown also proposed that the same body could account for something that had bothered astronomers for a long time. The Sun's rotation axis is tilted about 6 degrees relative to the plane the planets orbit in. The Sun spins slightly crooked compared to its own family. A massive planet on a tilted distant orbit, pulling on the whole planetary system for billions of years, would gradually tip that plane. 6 degrees is roughly what their model produced. It is a tidy explanation. It is not proof. A tidy explanation that fits 3 separate oddities is exactly what a correct theory looks like, and also exactly what a wrong theory looks like right before it collapses. Ask Vulcan. Now the counter-argument, because this channel does not skip it. Telescopes do not survey the sky evenly. They point where the weather is good, where the moon is not, where the observing time was allocated, where the sky is dark and uncluttered. If you only search certain patches of sky at certain times of year, then the objects you discover will naturally cluster, not because they are clustered in space, but because your search was clustered. In 2017, a team working with the Outer Solar System Origins Survey, led by Corey Shankman, examined their own detections of extreme distant objects with a carefully characterized survey, one where the biases were measured rather than assumed. Their sample did not show the clustering. They concluded that the observed alignment could plausibly be explained by observational bias, and that the evidence for a distant planet was weaker than it appeared. Batigan and Brown have pushed back, publishing later work arguing the clustering survives once biases are accounted for. Other groups have gone the other way. This is what a live scientific argument actually looks like, not a press release. 2 groups, the same sky, honestly disagreeing about whether a pattern in a sample of a dozen or so objects is a signal or an artifact. 6 objects, 1 in 14,000. Or one biased search producing a mirage. Researchers still cannot fully settle it, and anyone telling you otherwise is selling something. Then there is the strange option. In 2020, physicists Jakob Schultz and James Unwin published a paper asking a simple question. The evidence points to a compact source of gravity of roughly 5 to 10 Earth masses in the outer solar system. Nothing in the evidence requires that source to be a planet. It could be a primordial black hole, a hypothetical object formed in the first instance after the Big Bang, rather than from a collapsing star. A black hole of 5 Earth masses would be about the size of a grapefruit. It would reflect no light at all. Every search strategy built around spotting faint reflected sunlight would be pointed at the right patch of sky and see nothing, forever, because there is nothing there to reflect. The authors suggested it might instead be detectable through occasional flares of high-energy radiation as small bodies fall into it. There is no evidence that this is the case. It is not the leading explanation, and its own authors do not claim it is. But it illustrates the honest state of things. We have inferred a gravitational influence. We have not identified its source. A planet is the simplest answer. It is not the only one that fits. What we can say with confidence is what is not out there. In 2014, Kevin Luhman analyzed data from NASA's WISE mission, an infrared survey of the entire sky. Infrared matters because a large planet radiates its own residual heat rather than depending on reflected sunlight. The result ruled out a Saturn-sized object out to roughly 10,000 times Earth's distance from the Sun, and a Jupiter-sized object out to roughly 26,000 times. So the door is closed on a giant. Whatever might be out there is not a hidden gas giant. It sits in a narrow surviving window, big enough to herd distant objects, small and cold and dark enough to have evaded every survey we have ever run. That window is uncomfortably specific. It is also exactly the window the models predict. which is either a sign that the models are right or a sign that the hypothesis has been quietly reshaped every time a search came back empty. 10 Earth masses, 20,000 years, 6 aligned orbits, 600 times farther than we are. Still nothing in a photograph. This does not stay unresolved. In Chile, on a mountain called Cerro Pachón, the Vera C. Rubin Observatory began operations in 2025. It carries the largest digital camera ever built for astronomy, and it is designed to do one thing: photograph the entire visible southern sky, over and over, for 10 years. That is the legacy survey of space and time. It is precisely the instrument this problem has been waiting for, deep enough to reach objects far fainter than previous surveys, and repetitive enough to catch something that crawls. It will do two things. It will multiply the number of known extreme distant objects, turning a sample of 6 into a sample large enough to settle the bias argument on its own. And it may simply photograph the planet. The survey runs into the 2030s. That date is already on the calendar. By the end of it, one of two things will be true. Either there is a ninth planet, found by mathematics before it was ever seen, the way Neptune was in 1846, or the clustering dissolves. The pattern turns out to be an artifact of where we happen to be looking, and Planet 9 joins Vulcan. Either outcome is a real result. Only one of them gets headlines. 6 orbits, 10 Earth masses, 20,000 years for a single lap, 600 times farther from the Sun than you are right now. That is the whole case. 4 numbers, 1 improbability, and a stretch of sky we have never properly searched. We have mapped the surface of Pluto. We have landed on a comet. And we still cannot say with confidence how many planets orbit our own star. If it is out there, it has completed maybe 200,000 orbits since the solar system formed, and not one of them was ever witnessed. It will keep going, whether we confirm it or not. There is nothing out there to stop it. The telescope is running. The answer is coming this decade. If you want the rest of it as the data comes in, subscribe and turn on notifications. This channel covers real space discoveries, grounded in published research, rather than exaggerated headlines. No guessing, dressed up as certainty. Something may be hiding at the edge of our solar system. For the first time, we have built the thing that can look,